In this video, I'm going to describe a limit in the way I know about a limit, the way I think about a limit. So I wrote down a definition, and this is not something you would find in a textbook or the internet, but this is how I think of a limit. A limit is a y value, that is the anticipated result of calculating y values from x values that get closer and closer to a particular x value. So first thing I want to make really clear is a limit is a y value. It's a y value. It's an answer. It's an output. Um, it's an answer that you would get from plugging in an x value. But the problem with some function is that you can't actually substitute the x value you're really interested in substituting. So that's where that anticipated result comes from. I went online and I looked up a definition for a limit, and so I want to share that with you also. So this one out of the way. Okay, so here's something I did find online. Okay, they're really very good, very good, and you can look from this person that's being quoted here, uh, developed back in 1717. So a limit in terms of math is not very old because math, of course, goes back centuries. But the idea of a limit kind of goes like this, and I'll read along with it. It just says this. It says, when the value successively attributed to a variable approach indefinitely to a fixed value in a manner so as to end by differing from it by as little as wishes one wishes. This last is called the limit of all the others. Okay, that's a very good idea. And further on the bottom here, this is a very formal definition of a limit, which you would find in a textbook or the internet. And it goes like this: the limit of f of x as x approaches a equals capital L, if and only if for every epsilon greater than 0, there exists a delta greater than 0, so that if 0 is less than the absolute value of the difference of x and a. Yes, sir.